Hello everyone, my name is Suman Barua. In this tutorial, we will learn how to develop and train a machine learning model using Google Spreadsheet. In this process, we'll also learn preparing machine learning platform in Google Sheet, finding and processing datasets, using ChatGPT for generating machine learning datasets, refining, sanitizing and filtering datasets, training different machine learning models, predicting models with training datasets, comparative performance analysis of different models, testing models with test dataset, models performance evaluation, and also graph analysis. At the end, we will also export the trained model to Google Colab, and we'll see how to run the model in the Google Colab platform. Let's check out. At the beginning, we have to prepare Google Sheet platform for developing machine learning. So we will go to Google Sheet. Okay, so I'm already signed in. So if you are not signed in, then you have to sign in through using your Google account. So after signing, you will get this platform and you have to click on the blank file. And this is what is called Google Spreadsheet. Here, we will see how we can design and develop a machine learning model and train it. And then after that, we can also see the result, how it is working. And also at the end, we will export that to the Google Colab. So first, we have to install extension like simple ML for sheet. This extension is already installed here because I used that before, but for in your case maybe it is not installed. In that case you have to go to the add-ons, go to the get out add-ons, and here just search for simple ML first, then you will get this. Just click on that, and here because I have already installed here, so it is installed. For your case you have to click and install that. After installing, you will get this under this extension menu. If you don't get this, just reload this page, then you will get it here. So we are done with the environment installation. Now we will try to find out the dataset. So for the dataset, we can find out from some renowned source. For example, Kaggle. Kaggle is one of the renowned source. So you can see I found this data from here. So you can download this data, but you have to have the account here. So once you are logged in with the account, then you can download this data. After downloading, you can use that data, and the data will be CSV format. Well, so we can also use ChatGPT for generating machine learning dataset for us. For that, we need to give some command to it. For example, so I'm asking here to create 1000 rows of animal dataset, and duplicate is allowed. Also the data feature will be standard. So you can see it has created 10, but we can say very nice, please continue. Okay, so we can see that it is creating more. Let's see how it goes. So creating dataset using ChatGPT is also possible, but the problem is when you create a dataset using ChatGPT, then the dataset is not refined. In that case, you need to do more effort for refining all the data, because the classes are not defined, datasets are not well digitized, so there are so many things to consider. So it is possible, but it will take more time to refine and filter all the data. At this moment, we can see that it has created total 38. We can say continue, please continue, for printing more. So you can see that, as I said, please continue, it started from 39. So pretty cool. And you can see also some duplicate data, because I said the duplicate is allowed. Pretty cool. Yeah, so you know now that how we can also generate dataset using ChatGPT, but in that case we need to do some more refinement, more refining things. So that is the reason it is better to find some kind of dataset that is already refined and it has well label classed, so that you can just use that with ease. This data is already refined. just you have to use this in a proper way. So you can see I have already downloaded this data before. So you can see we have a test training dataset, test dataset, and the class. Well, so let's import this data into our spreadsheet. So how we can do that? File, open. I need to obviously upload because this data is still inside my local machine, so we have to upload that. So I'm uploading the training dataset. So let's open and let's see the drive. So okay, let's open this one. So I open this one, and also I want to open others also. So let's open and upload files. Let's upload this one. Now I'm testing, uploading the testing data. So this data also uploaded again. I'll upload class data. Cool. So I have uploaded almost everything. So let's see how it looks. So open test dataset. Also open class. Okay. So okay, let's explain a little bit. So here we can see that animal datasets, animal data features, everything. Let's just make it older because this is the header. So this is the header and these are the features, and we can see, and these are the animal names. You can see all the animal names: crab, deer, blah blah, dolphins. And also here you can see at the end we can see the class type. This is the class, this is the level class that we need to predict. Well, because this is the training data set, we already need to provide level class so that machine learning model can learn it. But when we will test, in that case, in the test data set, we will not provide this class. In that case, machine learning will predict that class, what would be the proper class for this particular animal, right? And we can see here feather, eggs, milk. These all are actually features, animal features. For example, how many legs, is it providing milk, it has feather, or blah blah, all the things. And the class type, maybe you will ask, what is this 1, 2, 3? What does this mean? So in that case, we have to open the class spreadsheet. You can see class spreadsheet here. We define the class as a digit so that machine learning model can understand that. But what is happening here? 1 is actually mammal, 2 is bird, 3 is reptile, 4 is fish, and other. You can see these are the meaning of this class, right? So in this particular class, we have so many animals. For example, 41 animals in mammal, 20 animals in bird class, 5 in reptile, blah blah. So when we talk about class, then we actually mean this, right? And now you can see that in the feature we can see only 1 and 0. Why is 1 and 0? This is actually true or false. For example, for this one, does it have here? So we can see that true, that means it has here. And for this one, bus, does it have here? No, it is saying that it is false, that means no. So you can see does it lay eggs, give milk, or blah blah things. So now you know that 1 and 0 is actually true and false detector. Right, now we can see also test dataset. So this is the test dataset. We separated four records for test and almost 98 record for training. So we will train the model using this data and test the model using this data, right? And also check the class using this data. So let's try. First of all, because we have already installed the extension here, so we need to start the extension. Let's start it. So once it is started, you will see a small panel for this. So this is the extension that will help us to build machine learning model. So you can see the small panel, and it has 2 sections. The top section with 3 features. These are actually used for data, data refining, sanitizing, or filtering stuff. So initially, when you start working with the dataset, that dataset maybe has some problem, maybe some data missing, some data is extremely abnormal, and you have to refine them. So in that case, you have to use these tools so that you can refine them. For example, our data class, for example, this one. So in this class, in this training dataset, we have all the class, all the data values exist. But what if we don't have some value? For example, we don't have this one. We don't have 4, and we don't have 7, right? What happens if we run the model with this dataset? Then our prediction will be biased. It will not be accurate. So in that case, we have to predict something here. We have to do something here. So in that case, we also cannot just say it can be 2, or this one can be 2, 3, or this one will be 2. No, not like that, because that is not the standard process. So in that case, we have to obviously follow the standard process. So in that case, what we can do, we can just go to predict missing values, and what column data we are missing, predicting, that is the class type. So select that one, and then just click on the predict button. So you can see the prediction is going on. Basically, the model is actually learning the whole data. Then you can see right now, the model predicts this data in this way. So we can see that there is a far difference. It was this one actually 4, this one actually was 4, and this one was 7, but we can see that it is 2.8 and 2.8, like 3 and 3 prediction. So at least better than you don't just case it, rather than you use this tool for finding the missing values. Okay, so all I wanted to show that how you can use this tool, and also if you have something like different values, for example, let's undo this one and let's return the original value. So for example, here we have a class 1 to 7, right? So in that case, if we can see that here we have a class 9 which is not defined, so this is called some kind of abnormal value. So we need to find out abnormal values using this tool. We can use this tool for finding that. So this one. Okay, so so undo this one. We have a 7. Yep. So right now, our first thing is we will train model. So we will train different model and see how each model results and performance, how they predict. So train first model. For example, this one we can give it. Okay, so this one may be model 1. Okay, and in model 1 we cannot take this, we cannot consider this class, this column as a feature, because this is just animal name. Machine learning does not know about this text and name. It only understands this numeric stuff. So we will remove this one. So we will remove name from the feature list, and these are the feature that we will use to train model, and this is the class type that we will predict later on. Okay, so at this moment we can go forward. We can see that there are 3 different machine learning models suggested by this tool. So for this type of data, we have 3 different models. One is the gradient boosted trees, another one is random forest, other one is the decision tree. So we can start from the first one, gradient boosted tree, and train model. Let's train model. We started training. So you can see the training process is going on with this given data. Yep. So training process is completed, and maybe we can train another model. For example, what if we can train other model, like, okay, we can train another model is like random forest, and we can give a title like model 2. Let's train it. So we are training another model. Okay, so we are done, and again we will train third model with the third type, like decision tree. Let's train it. So you can see the process is going on. Remember that we are here training 3 different models. You can see 3 different models. First one is the gradient boosted trees, second one is random forest, third one is the decision tree. Okay, so model 1 is actually gradient boosted tree, right? So right now we already trained 3 models, and right now we can test the prediction. We can test the prediction or how they predict. Okay, so we can click on that. You can see that our 3 models here: model 1, model 2, model 3. So model 1, we'll test with the model 1 first, because that is the first model that we trained with the gradient boosted trees, right? So if we click on predict, it will start predicting the data. So we can see a new class, predicted class here, predicted column here. Yep. So we can see the new predicted column here, but the predicted column is a floating point number, but we are actually using integer as class, right? So it's a floating point number. So we need to process something in this data. So in that case, we need to see how many data we have, like 98 records. Okay, so we need to round it, because we can see if we round it, because somehow we need to convert it into an integer. So we'll round it. We'll round. So S98. Okay. Okay, so we can see that we rounded, and we can for now just remove this one because it is not needed right now. So where the delete? Okay, delete column. Oh, I'm sorry. If I delete, then okay. So we cannot delete this right now. So we can name it So this column is the original class column, and this column is the predicted class column. Now what is the difference? So this is already given that this is already given with the data, and this one is predicted by our model, right? So this column is the main target for us, but we can see what is the difference between both column. original one and the predicted one. What is the deviation? What is the things? We can do some analysis. For example, for this one and this one, if we do some analysis, then what is the difference between the data, predicted data, and the given data? We can see almost same. We can see almost same data. Wow. We can see almost same prediction. So, but better to do some kind of analysis in the chart. So we can do some analysis using the line chart. You can see the line chart analysis is perfect. It's like you can see this blue line is the given class and this red line is the predicted class. See, given class and predicted class lying on each other. So there is no data misclass, nothing. So it's completely working well with the trained data set. But this right now we are working on the validation, and validation is actually on trained data set. So if we check the scatter plot, wow, we can see the scatter plot is completely straight line. That means the given data and the predicted data completely similar, right? So this way also we can evaluate the model, and other way also, for example, if we just delete this one, and also other way we can do that. Like if we go here, evaluate the model, click on evaluation, then it will evaluate the model, how it is working. So okay, so we can see here we have total 97 data, 97 prediction, all predicted, and we are using regression. This is the label class, and RMSE. This is really important things. RMSE means root mean squared error. Root mean squared error. This is really very important, performance indicator, we will say. But if you learn mathematical statistics, then you will understand what exactly this and how to calculate these things. But for now, the value is enough for us. So we can see the RMSE value is lower. Okay, so if it is lower, then it is better. So we can see the RMSE value is lower. That means we have less residuals, we have less error, more success, more good performance, right? And you can see also the growth is very nice, and yeah, all good. And yep, so we can see the performance is very good for this first model. Now we can see the second model, but before that we must remove this one, remove these two, because these two actually we used. These two are actually result from first model, so we are not using first model anymore. We will go for second one. So again we came back to the first initial form of the dataset, and again we'll predict the data with the second model. The second model was random forest. So right now we will test how random forest perform. Again we'll click on the prediction button. Let's see how it predicts. Okay, so again we can see the floating point number, so we can write it like create classes. So we need to use the rule for rounding. So it's 2 just like it. Okay, so we have the value right now, so we can see here also we have almost the same value for both the classes, same value. Wonderful. Wow. Okay, we can see one base class here. So original class is 7, predicted class is 6. So some deviation we can see in this model. So let's see the scatter plot and line chart. Let's see how it works. So chart, and go to the line chart. Oh wow, so we can see there are a lot of deviation actually in the random forest. So in the random forest we can see deviation 1, deviation 2, deviation 3, 4, 5, 6. So we can see that blue line and red line are not lying on each other. So these are the deviation we can also see in the scatter plot. So you can see scatter plot is not linear, so we can see some deviation. Cool. So we can say that the first model was actually better than the second model. Okay. So again we can see we can evaluate this model. Let's see how the evaluation going on. Definitely the error indicator will be higher so far. Yes, we can see the error indicator is higher than the previous one. So we can see 0.26 blah blah. So definitely the first one model is the better, this one. Let's see the third model. So, but before that we have to just remove these two, delete, and now our data is in the fresh form. Again we will make prediction on our third model, and the third model is the decision tree model. So let's predict. We can see the prediction is going on, and it will take few seconds and we'll get result. Boom. Yep. So again we have to do some let's do what is that? Red classes and rows round. Okay, so we can see almost similar. Well, almost similar. Okay, let's see how the chart analysis or graph analysis looks like. So we can see we can see the deviation. So we can see in this, so this model is actually decision tree. In the decision tree also we have a deviation here, 4 deviations, 1, 2, 3, 4, and so we see the scatter plot. Yep, we can see deviation 1, 2, 3, 4. Some deviations are here. So definitely the best result is from the first one, and the second best result is the decision tree, and the third best result is the random forest. So so let's remove this and we can see how it works. Remove. Again we'll predict with the model 1. So model 1 is actually gradient boosted tree, right? So that one is the best one, so predict 1 with that. Okay, cool. So let's name is create underscore classes, and then rules round S2 S98. So we have to select the column that we want to use in the chart. Okay, you can see the same result, completely 100% nice result. So also scatter plot, completely linear, so wonderful. So we can say that gradient boosted tree is one of the best model here for this data set, because we have already trained the model with this data and we are testing this with the same data. So this is just for validation, but this is not the correct way of checking the performance of the model, because the model already knows this data, right? So what if when we test the data which model doesn't know, it's completely new data set? So what happened? And that will be the true performance indicator, that will be the true test. Okay, so we can use the test data set for that purpose. So we can see in our test data set we have 4 in record, and we have also class here, but our model doesn't know about this data because we did not feed this data into that model. It's completely new set of data. So let's see what happens when we feed this data. So we will not use the data for training, rather than we will just evaluate the performance, make the prediction, right? So start the machine learning extension, and right now immediately we will go to the make predictions here, and we will test the model 1 because that is the model it is performing well. So let's predict here. Let's see how the prediction goes. Okay, wow. So let's use print classes. Okay, so let's use rule round. Okay, S2 to S5 maybe. Okay. So we can see here, wow, exactly the same. You can see 1177. Okay, 1 is class 5, and it identified as predicted as 4, but it's 3. That means result is very nice. Okay, so we can see that here the data class is really nicely predicted. Only 1 missing class. So we can see that our model is still performing well with the unseen data. These are the unseen data because we did not train the model using this data. This is completely new set of data for testing, right? So we can say that the model is performing well. Right now, we can do something else. We can see that gradient boosted tree algorithm is working truly well with this data set, right? So what we can do is right now we can export this data, export this model, because we think that the model is good and we can use that. Let's export this data, export this model. So you can see that it's going on exporting process. So we can see that it provides us the code for building the machine learning, training and testing the machine learning. So we'll copy this code and we will create the Colab. Google Colab is actually a very famous and good platform for developing machine learning models. So if you want to develop more complex model, writing the code, then in that case this is one of the best platform. So it also provides kind of a nice editor where you can edit the codes. It's just like if you have used Jupyter before, then you know how to do it. So let's open the new tab and new. So okay, we can see that so this is called Jupyter editor. This more comfortable editor. We paste the code that we got from the from our model, and we paste it. If we run it here, we will get the same things here. We will get the same model running everything, but you can see that all the code, if we click on the run, it will run all the code at once, but we will not run all the code at once. We will run one by one. So we have to separate this code, whole code block, in several different lines, several different sections, so that we can run every section separately and we can see if there is any problem or if how the data is coming along, right? So in that case, what we need to do, we need to take code panel. Okay, so we need to take the code panel. So for example, I want to separate this line here, and I want to label it as, move it to the top, label it as install. So yep, so install TensorFlow. Install TensorFlow package, and we will make it bolder so we can see. And again, we will separate the other block of the code like this, and we'll create new code panel, and this one we'll create a separate text so that we can put a header. Move it to the top and make it a bit smaller and bolder. Okay, so yep, we separated it, and again we'll separate this one, but before that we have to separate this first. Create new code panel, paste it here, and separate this one. Create a text panel, move it to the top. Make it smaller, make it bold. Okay, and again, this is actually the test data. Let's copy the whole portion and create another code panel. Just delete this one from here, and from this one delete this one. Separate this. Create a new text panel and use it here. Make it bold. So this here, this is not the correct header. So we need to just rename it. Okay, load test data set. That's it for testing the. Okay. Wonderful. So here also we have to do the same. We will create a test, move it to the top, copy this, put it here, okay, so border. So finally we separated all the lines, so we can run all the lines in a very separate way, right? So what happened? So in this case, we don't need to run our whole code at once. We can run one by one. Like for example, we just install TensorFlow. So we'll install the TensorFlow package. Just click on that. You can see the package installation started already. It will take some time, but I think it will be faster. Yep, almost. So it is installing the TensorFlow decision forest packages. Okay, done. So first step completed successfully. There is no error, and we will go for the second step. Let's see. In this step, transfer the model from Google Drive to Colab. So we develop the model in the Google spreadsheet, and that is saved into the Google Drive part. That is not inside the Colab, so we need to import that model in the Colab platform. So for that, we need to click on that to import the model. We need to give the access over, allow. Okay, so it is importing the model that we trained with the gradient boosted tree. Cool. So it is right now imported. Right now, prepare and load the model with TensorFlow. So this is the third step that we are running. So prepare and load the model with TensorFlow. So if we click on here, the imported model will be prepared and load here. We are loading the model that we trained before, but we are loading that in the Colab, Google Colab. We can see the model is loaded successfully, and right now we have to load the test data. We can see the test data we are loading. Loading is successful. Right now is the final stage. We have to just click on the prediction. So we have to click this test data, test unseen data. Click on that. So we can see the prediction is going on. Wow, that's really wonderful. So we can see Google Colab automatically created 3 rows. You can see row 1, row 2, and row 3. Right, 1, 2, and 3. So these 3 rows, actually these 3 animals, and we need to predict the class, which class these 3 animals belong to. Right. So we can see the first prediction is 1.0, that means 1. Second prediction is 6.9, that means 7. Third prediction is 3.7, that means 4. So finally, predicted values are actually 1, 7, 4. So we can see that we can train the model in the Google spreadsheet, and after training, when we are satisfied with the model, we can import that model to the Google Colab, and in the Google Colab also we can test the model as much as possible. So it's really wonderful. So that's all I wanted to show. Thanks a lot.